Welcome, everyone. Thank you for joining us for tonight's webinar, How To with your TI-84 Plus family of graphing calculators, Part 1. So whether you're working with an 84 Plus Silver Edition, a TI-84 CE, whatever graphing calculator you're using from the 84 family, there is something for everyone. As we get started, want to just be sure to say if you have video or audio difficulties, the session will be recorded. I'm going to actually send that out in the chat also because I see that Barbara doesn't have any audio, so I'm going to be sure send her a message that she can read later. The session will be recorded, so if you have audio or video issues that you can't resolve while we're working tonight, just tune in later. We'll have all the audio and video for you. I'm Ruth. I'm the moderator behind the scenes tonight. John and Stuart are the main show. Before we get to them officially, let's talk about the WebEx chat. Use the chat window to send comments and to ask questions. Open your chat window. It's the messaging icon. Please use everyone as your drop down over there. If you don't send it to everyone, if you just choose all attendees, unfortunately, none of us can see it. Neither John nor Stuart nor I. So drop down. Let's have a practice. Why don't you say hey to everybody, greetings, hello, your name, and where are you? Okay. Take a chance to look up and down the chat window. Greetings. Oh, nice. All right. Looking good there. So that's about all I need to do. We are ready. Our presenters this evening are John Lemaster and Stuart Muskowski, and I've been practicing, so thank you. I've gotten better. And Stuart and John, tell us about yourselves, and thank you in advance for everything you're going to share with us tonight.
Absolutely. Hi, I'm John Lemaster. I'm from Fort Wayne, Indiana. That's a virtual background. I really do not live in the swamp. I'm not a troll, but it's very peaceful and calming. And I'm thrilled to be part of this tonight with you.
Stuart, I can do better. Moskowitz.
I'm Stuart Moskowitz. No worries, Ruth. I'm here about 300 miles north of the Golden Gate Bridge. That's the redwood forest out there out the window, and that's my real kitchen. No virtual kitchen there. I recently retired from Humboldt State University, now known as Cal Poly Humboldt. Nice to be here.
Thank you both.
So here's our lineup of activities, and they all involve the home screen. This is part one of a series, and Stuart and I wanted to dedicate this webinar just on this because, well, there's so much you can do with it. And, you know, like a line from a good movie, there's no place like home. So if we look at this agenda, we'll come back to it periodically through the webinar, but the next slide will share just some expected outcomes. And on this slide, you know, I hope after you leave, you'll be more comfortable with these outcomes. And notice the last one, helping other teachers or your students. And all our glitches, as we like to say to our students, all our glitches are absolutely intentional. So they teach us and you how to recover from misadventures. As we mentioned, this is a recorded webinar, which gives you an opportunity to able to not, we don't think it for your best enjoyment, you should follow along with your calculator. In fact, we discourage it because if you go to the recording later, then with your calculator, you can do the activities at a pace that's really right just for you. So as we put all this information forward, we're going to probably go faster than probably one would do if this were a real workshop. So Stuart, thank you for starting us off. We'll turn it over to you.
Okay, thank you, John. I'm going to start by sharing my screen. And I want to address, I see a question out there about part 2. We said that this was going to be part 1 was going to focus on the home screen, and part 2 will be focusing on the graphing capabilities of this graphing calculator. So let's see, the first thing I want to do here, make it a little less distracting so that you can see the screen. Now I have a very cluttered screen, so I want to start by doing something that I do every time I pass out a set of calculators to a new group of students or teachers, and that's to reset the calculator so that we're all on the same page. And to do that, I'm going to go to the memory page. Now to get to memory, which is written in blue above the plus key, I'm going to go second memory, and I'm going to choose number 7, reset. Now I can choose number 7 two different ways. I can go down, 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 down all the way to 7 and press enter, or I can simply press 7. I don't want to press 7 and enter, because then 7 enter, then we'll execute the next line here. So 7 got me to this page. I don't want to reset RAM, because what that's going to do is it'll erase programs, it'll erase lists. I don't want to erase anything from my calculator. I merely want to reset the default settings so that screens are clear, and the graph settings and you notice these settings up at the top of the screen. That way we'll all be on the same page when we start. See that CL right there? When I say defaults, I want to look at that. It's giving me a chance to change my mind. I do want to reset the defaults. I'm going to press number 2 again. And now notice that CL changed to an MP, and we're going to talk about that very, very quickly here. In fact, I'm going to go straight to mode. I'm going to go straight to the mode menu, but I guess I really should back up. And again, since this is an introduction, and I know some of you are beginners, some of you have already spent time with the calculator. Every time I get a new tour, I always learn something new every time. So let me just say a little bit that the white keys, this is my basic 4-function calculator. The reason the 2 is red is because that's the last key that I pressed. I'll press clear just to erase that. So the white keys is my basic calculator. We have the rows above are my scientific functions that I would see on a typical scientific calculator, also logs, natural logs, trig functions. We have the graph settings up on the top row, and then we get lots of other settings, programs and applications, lots more in the middle here. And we're going to talk about a lot of it in this hour, but we certainly can't possibly cover everything. But mode is a real good place to start. So let's go to mode, and there's a lot here. By resetting defaults, notice everything here is on the left. And so I'm going to start by talking, again, math print versus classic. We'll get to a few of these. I want to say that the function parametric polar sequence, I want to make a little comment about that, because I have a key right here. And when I say here, I'm using my mouse pointer. So hopefully you can follow that. I tried to make it big and colorful for you. This XT theta N key is important, very important one, because we have the whole alphabet that we can access with the alpha. And we could go alpha X, but X is used so often, they gave it a dedicated key. But then there's a T and a theta and an N as well. And that depends on which graphing mode we're in. If we were to switch to parametric mode, that would be a T key. If we go to polar mode, we'd have a theta. Sequence, of course, would be would give us the N. We also get some other graph settings where we can have the lines be thick or dotted. We can have multiple graphs graphing sequentially or simultaneous, but we're going to save all that for part 2. So so for right now, let's go back up, math print versus classic, and what does that mean? And so I'm going to just leave it on math print, and I'm going to go back to the home screen. Now I have 2 ways I can get to the home screen. This clear key is what seems to be used most and obviously the clear button on many calculators sort of wipes everything out. And sure enough, if I press clear, it's going to take me back to the home screen. It just did. But I want to warn you, don't rely on clear to go back to the home screen. Just as an example, notice that I have a function here in Y1. If I was to press clear, I just erased it. And I didn't want to erase it, and there's no way to bring it back. So clear will take you back to the home screen unless you're on a line that can be edited. Since I can type on this line, clear is going to erase the entire line. Delete will only erase what's underneath the cursor. If you want to go back to the home screen, and you can do that anywhere you're at, use quit, and quit is the second function above mode. So I'm going to go second, quit, I'm back at the home screen. All right. I mentioned this math print mode that we're in, and what's so nice about it. Let's do a quick example. Exponents is a good way to see this. I want to think about, let's see, 3 to the 5th power. Well, I have a caret key. Now on older calculators and anything that is text-based, that caret would show up on the screen. But in math print, I actually get a superscript. I love it because I can type the way I would write it with a pencil. And that's so important, you know, so it makes it much easier to go back and forth. And now I can type 3 to the 5th. Now I need to be careful here. Notice that the cursor is up here in the superscript. So if I wanted to do 3 to the 5th plus 4, I would have to move out of I got to use the arrow key to get out of the superscript. And now I can type plus 4 and then hit enter to get the result. Okay. Another example where this is so important here, and let's see, I mentioned that there's lots of stuff on this line right here, especially this math menu. And so what I want to do is go to math, and you can see that we have lots of functions here under math. We can convert to fraction, convert to decimal. We actually have a dedicated cubed function, although I don't ever use this anymore because I can use the caret key and just type for cubed right there on the home screen. I don't need a menu. I also have a square root key, but if I want to get other roots, and I'll look at that in just a little bit, we'll use these keys here, number 4 and 5. And we can do numerical derivatives and we can do numerical integrals, the minimums of functions, maximums. Notice this arrow that tells me there's more than 9. So I could go down, 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 but I'm just going to go up to see what's there and to see the rest of it. I can do logs and other bases, piecewise functions. We even have a numeric solver in here. Again, way more than we can do in 1 hour. And I see that I wanted to show you this summation key, but I want you to see that I had to go into mode, to scroll down and to get to the bottom of this math submenu. Of course, we haven't even talked about all these other menus that are here. We'll come back to that in a bit. And I want to show you that there's more than one way to get to summation. I'm going to go back to the home screen, second quit, and I want you to see that above the graph keys, I have function keys, F1 through F5. Now, those will mean different things depending on the application that I'm in. But if I'm on the home screen and I go to F1, alpha F1, I bring up all my fraction templates. And it's very nice to see that there. Okay, I'm going to let John talk about the fraction. He'll talk more about that in just a little bit. I'm going to go alpha F2, and I see many of the frequently used math functions that we saw a little while ago. Of course, permutations and combinations, we'll find those in the probability submenu. I mentioned the summation. And what's nice here is that I see summation here with the parenthesis, and that's the classic way to do it as text. But then I also see the summation here and all of these math print ways of doing it. So let me just choose number 2. I'll type 2, and look, it gives me all of it, all the things that I need to make this happen. So I'm going to say, let's let x equal 1. I'll use the up arrow, maybe just 1 to 5, and we're just going to keep this very, very straightforward here. How about just let's take x as x goes from 1 to 5 and add them up. That's all. I'm just trying to show you how this works, and then so that you can see what it looks like. So I go to enter, and of course, 1 plus 2 plus 3 plus 4 plus 5 is 15. If I go back to mode and change it to classic and go back to the home screen, now the screen is clear, but if I hit the up arrow key, I can go through the history and see other things that are there. There's summation, but here's what it looks like in classic. And you can either go to the manual, or there's actually a manual built into the TI-84. It's above the catalog is above the 0 key, and we'll try to revisit that later. But this is why Math Print is so nice, because it looks the way we would write it and much more intuitive. We need to understand what each of these arguments means. I still get the same result. I can press enter to paste it and then execute it just like this. Okay, one more thing on the mode menu I want to show you right now. I have an option of displaying the output in scientific or engineering notation, and a floating decimal point. Let's talk about what a floating decimal point means. If I go 1 divided by 2, it's going to give me an exact answer of 0.05, 0.5. If I go 1 divided by 3, since that's a repeating decimal, it's going to show me as many digits as it can. It's going to show me the fewest number to give me the best answer. 1/2, it only needed 1 decimal digit. But 1/3, since it's going to go on forever, it's going to fill up the screen. Now, you may say, well, that's too many decimal digits. Is there any way we can shorten that? And certainly we can. We certainly can. So if I go back to mode, and instead of a floating decimal point, let's say we just want to show 2 decimal digits at a time, let's fix it at 2. So we're going to change it to 2, and I'm going to go to enter. I got to remember to say please. So my please key is enter. So I'm going to go here, I press enter. I'm now at 2 decimal digits. I notice I'm still on classic, so let's go back to Math Print. I'll say please. I'll go back to the home screen. That's quit. And now I'm going to go back and I'm going to grab that 1/3. I probably should say it's not 1, really. It's 1 divided by 3 at this point. It's going to give me that decimal approximation. But notice that 1 divided by 2 now also shows me 2 digits. So everything is going to be giving me 2 decimal digits. In fact, even 3 plus 5 gives me 2 decimal digits. Now, I mentioned misadventures. That's part of our agenda. So I want to address this because I occasionally have students that they don't like seeing this 8.00 when all they want is 8. So they go back to mode on their own and they change it. They don't want to see those digits, so they'll change it to 0. And then they come back to the home screen, and 3 plus 5. Now watch, I'm going to execute 3 plus 5 again, but all I'm going to do is hit enter. If you have a cursor on a blank line and you press enter, all that happens is it executes the previous entry line. And now 3 plus 5 is certainly 8. But watch what happens here. I'm going to go up, up. I can get the previous line. All I have to do is press enter and execute the previous line. If I want to get another line in the history, I'm going to go up. I just use the up arrow key. So I'm going to highlight 1/2. I'm going to press enter to paste it on the edit line. And now I press enter to execute it. And 1 divided by 2 is 1. That is not a good thing, to say the least. And so students will go, what's going on? How come my calculator seems to keep getting the wrong answer? Why is 7 divided by 3 equal to 2? So again, remember, we didn't say, what we said was, yes, fix it at 0, but this also means round it to 0 decimal digits. So I don't think I've ever chosen to use fix at 0. I certainly much prefer floating a floating decimal point. Okay, so let's move forward. A couple more things here in the mode menu while we're here. I want to just let you know that answers auto versus decimal. If you want to get a decimal approximation, change it to decimal. If you would like to see an exact answer, if possible, then choose auto. And it will give you a fractional answer, an exact answer, if it can. Statistical diagnostics. The diagnostics means if you're doing any statistical analysis, the default setting keeps the correlation coefficient R and R squared. It keeps those turned off. So that's what that is. And the wizards allow me to do statistical analyses sort of like math print. Without the wizards, then I would be doing it text-based on the home screen, and it's a little bit more cumbersome. So I like having the wizards turned on. Notice we also have a clock. Notice that my clock is not set. With the emulator, with this software, when the computer is shut down and then we have to, fire it back up, it resets everything. So I have not found myself setting the clock. And you have many languages to choose from if you have any second language learners in your classroom. So let's go back to the home screen, do a couple more things here. Second, quit. And then let's see, misadventures. 5 subtract 3. 5 subtract 3. Uh-oh. I thought that's not what I wanted. Why do I get negative 15? Well, let's try this again. 5 subtract 3. And now, of course, I get 2. So what's the difference? Notice, look at these two symbols. This one is a little bit higher and it's a little bit shorter. That's the negation key, not the subtraction key. And the calculator knows the difference. So it actually interpreted this as 5 times negative 3. Now, a really interesting little bit of information here is that on my older calculators, even the first 84 plus CE that I had, 5 times negative 3 would give me an error. Now it is able to do the computation. On your 84 plus, the black and whites, those will give you an error if you try to use the negation key instead of subtraction. So be very, very careful. And if a student comes up to you and says, why am I getting a different answer? Pay attention to the symbol. It's really important to, it's very important to make sure that you have the correct symbol and that you as the teacher know the difference. All I want to say to add, the last thing I want to say here is that, yes, older calculators gave me errors, but now that's not necessarily the case. So this is the only graph I'm going to show you today. X subtract 3, whoops, but I want to do this with the negation key, X subtract 3, and I press graph, and sure enough, I'm showing you this as a misadventure because you hear the argument that students shouldn't use calculators because they'll never learn any mathematics. And I'd like to argue that students can't use a calculator if they don't know the mathematics. They won't be able to be successful with the calculator. I want them to ask, does this make sense? X subtract 3 should have a positive slope. And so right away, I see something is wrong. And so, yes, of course, this is the graph of negative 3x. So that's the first little bit here. I'm going to turn it over to John. All right, the ball is in your court, John.
Okay, I think we're seeing John's screen here. We have a document camera, and I'm not sure if John is muted or not, but pretty soon we'll be hearing something.
Thank you, Ruth. I was muted. It's so nice to have friends out there helping me. And it's so funny. How many times have we been on a WebEx or a Zoom in our class and it's like, you are on mute. And here you are. So I'd just like to share with you that what I'm going to do, you may be able to replicate as long as your operating system is up to date. And the latest on the 84 Plus would be 2.55 MP. And to get there, I'm going to press second, memory, and then number 1, about. And notice that that's different number than this one. And this is the latest for the Python 5.7, which is different than the actual 84, which if we go here, second, memory, about, this is the latest for the 84 CE. So it isn't always the same number. That means that you're updated. And what I'd like to show you is something with fractions, which if we were on an 83 or an non-updated calculator, then I would get an unhappy looking result here if I wanted to see a pattern. And what I can do is, this is a fun thing to show, is that if I go to the math menu, there's this favorite button of mine called frac, which changes my fraction to my decimal to a fraction. And I can also go into math and show you that at the bottom, remember I can press the up arrow to get to the bottom, that I can do F over D, or F to D and D to F. And it toggles. But what's awesome, and Stuart hinted to this earlier, which we're going to review, is that it shows right here, the N over D key. And so I'm going to press number 1. I pressed, how did I get there? I went alpha y equal, or F1. And I'd like to, well, here's the idea with the activity. What I'd like to do is show you the kind of pattern here of these fractions, adding them up, and they're going to be stacked fractions rather than the fractions that were on the earlier history that use the division key. This does not use the division key, and it'll give us something as a better result. We don't have to frac it then. So just to remind you, how did we get that? We'll start at the top here. We can get math, or we can go alpha y equal and number 1. And the first part of that was take 1/2 and add it to 1/3. But here's an added bonus. If you might notice this green little stacked fraction, this is true whether you have an 84 plus CE Python or whether you have an 84 plus CE. And that is a hidden Easter egg. And that little Easter egg, it saves you just a little bit of time. And now look what we've got, a 5 over 6. And to use my home screen, what I'd like to do is climb to the tippy top here and press enter. And I'm going to pluck it down by hitting enter and then going back. Now, one way is to press the left arrow and change this to a 4. And here we have 7/12. And now the next thing, I'm going to climb back up here and keep building this. And what's neat about this is I ask my students, do they see a pattern? And I'm asking that for you. Do you see a pattern in the chat? And what might come next? By the way, if I wanted 1/5 plus 1/6, here's another cute way to get to all the way to the beginning. Second left, and that takes me all the way to the expression, and then I can get this. So the nice thing about this is that there's lots of patterns coming on. I noticed that some of this in the chat, that your denominators are the product and the numerators are the sum. That's awesome. And someone else, you might notice that there is a lot of other ways to, oh, yep. So the next one, 3, 5, 7, 9, 11, we probably get a 13. And so that is great. There's lots of patterns one can get with these. So one of the things that, ooh, that's cool. The sequence of the denominators are Savannah pointed out, the rectangular numbers. So what I'd like to do is ask, does it work for any number? And here I can now build that and I put a little PowerPoint where this actually gets you to the algebra. And so you and I know that this is a hard thing to motivate students to say, well, at least mine, they say, oh, give me another one. Well, I'm not sure if I can build an exploration on the home screen and say, do you think it's true for everything? Well, they get their friendly least common denominator, and then they'd add them, and they'd say exactly what you pointed out, that the sum of the denominators of the question is the results sum, and the denominator is the product. So it's sort of a cool way to build that kind of exploration. The other thing that I'd like to show you just briefly is that I can actually write this now in a value where I use x, and x is a variable that's being used by the calculator. So it's dangerous sometimes to use it and then think it's going to stay in there. But right now, my x and your x may or may not be the same. And so I just decided to put that x there, and it's going to evaluate this because x is somehow has a number stored in it. Now I'm going to ask, what do you think is the number x? I haven't told you, but if you see the pattern of the product and the sum, oh, Barb, good job. So 20, and you're kind of getting this sort of question here, rephrased, and that you're asking, where do you find, something that involves, oh, I have a sum and I have a product. What are the two numbers that make the sum? What are the two numbers, those two numbers that also make this product? And that actually occurs later in a curriculum. Does anyone know what that might be? Where we see that later in the curriculum? Oh, yep, factoring. Yeah, exactly, factoring. And oh, I see the diamond problems. These are exactly diamond problems. Thank you for sharing that link. So is it really 20? Here's what we can do. We can store 20 into X, and then I can go replay the command, and I will now then see that I did get the same thing. I can also do that on the same line. So if I hit 20 store and then hit colon and then pop this up, see how I don't have to retype anything. Oh, I forgot something, intentionally, of course. And now I'm going to go back here and just insert. So this is a nice way to share the insert cursor. We need the blue insert. So we hit second insert, and then notice how the cursor changes. It's not over strike. And that's all we're going to do from this one. But there's lots of the ways to check this. And you'll notice too that, oh, you could have, if you're on a screen where you're in SmartView and you don't want them to see what you did for 20, and you hide it behind the screen, you can actually go under the hood here where all of the contents and the variables are there. And you can drag things off of this onto your computer and drag things back in. So here was my x equal 20. So if my calculator changes it, all I have to do is drag that thing in there, and now my x is 20 again, even if I've changed it. Now, Stuart, I want to return the ball to you.
Wait, John, just a minute. Just to hold on. Before
I
you,
will
oh,
not
too
stop
late. I was going to
sharing.
say, when you went under the hood, what did you do?
I
We were
did.
looking at your calculator emulator, and then you said, go under the hood.
Thank
What
you
did that mean?
in that. I went over to this corner here, and this is actually the emulator. There's two buttons over here on the left. And this, if I hover over it, it'll tell me it's called the Emulator Explorer Workspace. And that's
I'm not seeing that on your screen right now. Maybe I
um
missed it.
let's see.
Oh,
Is it
it's
not because
hiding over there.
it's hiding because I believe I need to share something. And let me get to my WebEx here. Well, that's interesting. I'm sharing the wrong screen. That's it. Stop sharing. You know what, Ruth? Thank you
Okay.
very much. It is great when you share the correct screen. And that is it. So this is it. And let's see. We'll go back to my emulator. There it is. Behold, that's it right there. Thank you, Ruth. This is the emulator, and this is the screen. We haven't been bumping tonight. This is the button that gives you all the stuff under the hood. And you can drag this in, and it'll ask you, you sure you're going to replace it? And it now is changed. Or you can drag anything out. So if you wanted to save stuff out of your calculator and put it on your computer, that's how you do it. All right. Thanks for asking that. Did you have any other questions? Cool. So we'll stop sharing and give you back the ball, Stuart, for math templates.
Excellent. All right, let's see. Where's the ball? All right, there's the ball. So I'm going to share my screen again, and I want to let's see. We'll go back to my emulator. I hope you can see it okay right now, that I'm sharing the right one. We make lots of mistakes. It doesn't matter how long you've been teaching. We're always, and we make lots of them on purpose. And so that's one reason why it's really nice to team teach, because we can always, this is a good way to help others see where some of the differences. And that extra screen, what John was talking about, is way over here on the left. If I just click right there, that takes me into the directory of my emulators. But I'm going to go back. I don't want to spend any more time there right now. What I want to do is I want to square -3. -3, and I don't need to go to the exponent key. I want to go right here to the x squared key, and there it is, -3 squared. And I know that, you know, if you've been a math teacher, you know this mistake. You know that students have this is almost a misleading little bit of order of operations. What comes first, exponents or negation? And I think it's pretty clear when we look at we look at this output, that what's happening is it's the exponent that comes first. So we are taking the opposite of 3 squared. And so that's why I sure like having these parentheses close by. Parentheses -3 squared, and then I can get the 9 that I was hoping to get. Now, I showed you that x squared key. There's that square root key, second square root. Now, notice it gives me a paren. And so I want to take, but that's because I'm in classic mode right here. I'm back in classic mode. So everything is text-based. So let's type this, let's see, the square root of 4 times, and I'm going to use implied multiplication here, the square root of 4 times -4. And this is one reason why I don't like classic. What's this going to do? What should get priority? Order of operations for the, order of operations is in some ways really depends on it's arbitrary. So what did the programmers decide? Go back to older calculators, and you might be surprised to see the answer. When I press enter, we get what we would hope. Yes, absolutely, Sharon, that's a -8. Square, 2 times -4. But on older models of calculators, this would have given me an error, a domain error, if on a calculator that has only real numbers, and it would have given me let's see, it would be the square root of -16, or 4i, on a calculator that has complex notation. But again, this is classic. Let's go back to mode. Let's get back into math print mode. And I think it's really important to see why this is so critical. Let's go back. I'm going to go up and grab that. Notice now in classic, we don't have the same issue of just what the heck does it mean. So I'm real glad to see this. One other example of how how nice it is to have this math print mode. Now I can go to math. I want absolute value. Well, I haven't gone to this number menu yet, so I'm going to go over to number. This is where I get absolute value. And notice everything has the parentheses. So in classic mode, you're going to see that parenthesis, but it may not always be obvious. Lowest common multiple, greatest common divisor. If I go to the bottom, we can see all the fraction commands that John was just showing you. Interestingly, the fraction commands, and let's see, I don't know, John, if you mentioned this, they're actually in 3 different locations on the calculator. They're at the bottom of the number menu. If I go right over to fraction, I see them in the fraction submenu. But then John also showed you that they're going to be up there under F1 as well. Well, there's a lot here in this math menu, the stuff that we use a lot. I'm going to go back to the home screen. I want absolute value, so I'm going to go alpha F2. And again, I see commonly used ones. Now, even though I see the paren here, because I'm in math print mode, I'm going to get what's in blue over here on the right. So I'm going to choose number 1. Since it's highlighted, I can press 1 or enter. Doesn't make any difference. And well, actually here, let's see what happens. If I want the square root of -6, but I accidentally type the subtraction key, I get a syntax error. And as I said, I make lots of mistakes on purpose. And this one I did make on purpose because I want you, what does it mean, syntax? I like to think of syntax as grammar, okay? And so the calculator doesn't understand bad grammar. I'm going to choose go to the location of the error, and it's flashing where it had trouble because subtraction is a binary operation. It needs 2 inputs, and it needs a number before and a number after. So let's change that subtraction key to a unary operation. Negation is unary. All we need is -6, and of course we get 6. This idea of binary operations, if I want to take that 6 and let's see, I want to take that answer and subtract 4. Notice I didn't type answer, I just hit subtraction. And the calculator knows that subtraction is a binary operation. If you don't put an argument in front of it, it's going to by default grab the previous answer. So even though I didn't type 6, it's going to go grab it. Now, if I type enter again, it won't give me 2 again because the answer isn't 6 anymore. The answer is now 2. So if I just hit enter, I'm going to get -2. And each time I hit enter, notice we get this recursion. And I want to talk a little bit more about recursion here. So I'm going to move forward and present a situation here. Let's call it choose a prize, and you'll see the activity in the handouts later on. Choose a prize. Okay, you've won the contest, and now you get to choose which prize you're going to get, and you're not going to get the prize until the 20th day. And you get 2 choices. We can start with $100 and keep adding $100 to the amount every day, or we can start with a penny and we'll double it every day. So obviously, $100 versus a penny, there's not much decision there. But what if we did this for 20 days? So let me talk a little more about iteration here. If I put 100 into the calculator, and actually what I'm going to do is I'm going to clear my screen because I like to start a new activity on a clean screen here. So I put 100 in. I don't do any operation on it. Now I say plus 100, and I keep hitting enter, 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 and I see that it keeps adding $100. I like that very much, but I have to keep counting. I guess it's not so hard to count when it's, since I know this is the 6th day, $600. But if I put a penny in and then multiply times 2, but of course it's answer times 2, it's not so easy to keep track. I really do have to count. So what I want to show you not only is the recursion, but the power of this calculator with a big screen. Even if you never ever do any graphing, having a large screen on your calculator allows you to do more complicated, more complex functions, more complex things, more activities. So I want to do all of this at once, and I would really like to keep track. So what I'm going to do is build a list. There's three things I want to do. And notice what I did here is I went second and hit the paren key, but I'm getting a curly bracket. And that means I'm starting a list. And so I'm going to have three elements in this list. The first element will be the day. Let's start with day 1. I'll use a comma to separate the elements. The second element will be the first choice, which is $100 on the first day, comma. And the third choice is going to be, whoops, not 2 cents. I'm going to go back. Now I could delete the 2 and then type 1, or because I have a strike over cursor, I'm just going to type 1. And it goes right on top of it and replaces it. And now I'm going to go second, close the paren, and press enter. So here we go. I have 3 answers all at once. I want to do 3 computations at once. And I have a big screen so I can see all 3 of them. Now, I'm going to go back. So let's see. I want to do 3 things at once. I want to take the first answer. And so when answer is the beginning of the line, I don't need to type it, but it's not at the beginning of the line anymore. So I'm going to go second, and above the negation key, I have the answer command. And so I want to take the day and keep adding 1. And now I want to take, well, oops, I made a mistake. What I want is the first answer. I want the first answer. So instead of going back and restarting, I would like to insert first answer between answer and plus. So I want to paste a 1 in parentheses to the left of the plus sign. So this is where I want to do the inserting. I want to push everything over. This is where this insert cursor comes in. Second, I'm going to change the cursor to insert. Be careful. Make sure you get that second key, because if you don't, you're going to delete instead of insert. So now I have an insert cursor, which will allow me to type paren 1, close paren. So that means first answer plus 1. And now I'll use the arrow key to come back out. And by the way, to update the operating system is something we won't be doing today. You can link 2 calculators together and send the operating system from one to another using the link command, or you can use the TI Connect free software, and it will, you can download it from the computer. You can get it from the website and download it from the computer. It's actually faster to do it from calculator to calculator. So let's see. Okay, as I said, that's something we can address later. And I want to say that the handouts that you'll get will have both of our emails on it. Please don't hesitate. Any questions that come up, we always give a lifetime guarantee with our workshops. That means you can come to us with questions anytime, day or night. And we're both night owls. So hopefully, John, yep, John, I know you're a night owl. So please don't hesitate to ask us questions down the road. No problem. Okay, second answer. That's my first option. I'm going to add 100 to it, comma. And now I'm going to take the third answer. So I have to go answer, parentheses 3, and I'm going to multiply times, whoops, not by a decimal point. I'm going to multiply times 2, and I'm going to close that. Now notice what happened here is that this is such a long command that I can't see the beginning of it. And that's a little bit disconcerting here when you want to be able to see it. Okay, so let me go ahead and press enter so we can see what's happened. Notice it did all 3 of them. We now are on the second day, $200 with the first choice and 2 cents with the third choice. With the second choice, I mean, I'm in the third element, but I don't like the fact that I can't see. I can press enter again, and it'll keep doing it. There's the third day. But if you want to see long commands that are scrolling off the screen, here's the only time I like classic mode. So let me go back to math, print, Let's change it back to mode, change to classic. Don't forget to say please. Second, quit. Can't see anything there, but if I just press enter, it'll come back. I'll re-execute the last line. Notice that in classic mode, it actually does, instead of scrolling off the screen, it does a wraparound and I can see the entire line. And now it's just a matter of pressing enter over and over again. And the question was, you don't get the prize until the 20th day. And look, after 10 days, I sure want the first option. After 15 days, I still want the first option, but that doubling is catching up. And by the time we get to the 19th day, it passes. And on the 20th day, of course, they get a lot more money with the second option. So I've got lots more to share, but I want to give John some more time. So let's pass the ball back to John. Here you go, John. I'm going to stop sharing.
Great. Actually, I've figured out how to unmute. And what I'd like to share with you is a screen that kind of ties in the connection with the, oh, there we go, get that out of the way. We don't need the emails there, where I've inserted a 1, and what I'd like to do next is just share with you one little cute pattern array generator by using the answer and a stacked fraction. And what will happen is another set of fractions occurs, which kind of is neat. If you've got students who are involved in computers, they may recognize the denominators, and you may recognize the numerators if you've done any work in the field. And what's, I think, very interesting about this is what happens if I keep doing this and never stop, and that it actually converges. And I like to use the word converge even at an early level, where that it will sooner or later come to a number, and the calculator calls that 2. But if 2 is the answer, this entry right here is now 1 plus 2 over 2, and we get our convergence value. Now, what's interesting about this is there's some rich mathematics that's kind of fun, because what I've just shown is if I keep pressing this enter button, it gets finally to where whatever my answer was, now I have as my new value, and it repeats to it. So if you'll notice, 2 is the answer, and now it is actually the result. And if I solve this equation, I'll find out that there's only one value, and it's because it's linear, and that's the actual value. Not only that, this is really beautiful to me, that this was the answer, and now I take 1 plus the answer, and I really have a continued fraction going on. And this just blows my mind that my calculator was able to build this continued fraction and say it's 2. And what's awesome about this, and we won't have time to go into it, but you'll get this big handout, which will then explore what happens if you change these results, and then some of them are quadratic, some of them have surprises, and they have pretty numbers. There's a lot of rich stuff in here. If you're teaching calculus, you could go into Newton's method with this. And so it's a cute way to bring in kind of the home screen in a fun activity. Now, we've just got enough time for Ruth to conclude with some Q&A, webinar, and drawing and announcements. So, Ruth,
Thank you so much, John and Stuart. Remember, you can still put questions and comments in the chat while we're finishing. And also, as you leave the webinar tonight via WebEx, you have an opportunity to save the chat. There's lots of interesting comments, useful links, and you can save that chat I don't believe it's automatic the way it is with some other platforms, but yes, maybe it is. Somebody will tell me that in the chat here in just a minute. So thank you for all of those things. We had an opportunity to look and see and learn, and remember, this is all recorded. I can go back and watch it again and try it myself, and you'll have the documents. You'll get an email that will share information of how to find the link with the documents for tonight's session. All right. There is a webinar drawing. This is for a free registration for the 2022 virtual T-Cubed International Conference. And the winner is Seth Youngen. Congratulations. Shout out to Seth. And the winner is, I'm going to try to type it and say it so that we'll have an artifact of it in the chat. All right. Okay. Oh, I love Sharon's comment there, so I hope everybody got to see it.
Oh,
There's
yeah.
always something to learn. Thank you.
That means
And
that means a lot to me, Sharon. I appreciate that very much to hear that.
as we continue, congratulations to Seth there. Let's see what's on the next slide. I think it might be how to get your certificate of attendance for tonight's webinar. I'm going to share that link in the chat. It will also be in the documents that you can download later. Okay, your certificate of attendance for tonight. All right, that is all I need to say. We've announced the winner, yay, Seth, and we've shared the link for certificate of attendance.
And if you think of a
Post-webinar
question
follow-up.
afterwards, just
Yes,
email us.
go
Sorry,
ahead.
I jumped on top of you. I was just going to say, if you think of a question afterwards, email us. Just a reminder.
Yes, even after the show is over, they are always happy to get your questions and comments. And don't forget, this was part 1. There's a part 2. Gentlemen, what is the date of part 2? It was April 20 something. I know somebody registered for it tonight.
Yeah, scroll the chat. It's in there.
Yep, it sure is. Okay, I'm going to keep things going here just in case we have some information, questions in the chat to share. Somebody wants to pop on and send out info or anything. And thank you, Stuart. Thank you, John. Thank you, attendees, for being with us tonight.
Thank you, Ruth.
Thank you so much.
Okay, we have 3 minutes. I'm not going to shut her down. Let's keep it going. Oh, yes, good stuff coming in the chat. Thank you.
They say sequels can sometimes even be better than the original. We'll see.
Oh, and I did want to say, I know that there are people watching tonight who will watch it again, but also their colleagues didn't have a chance to register or had a conflict tonight. So what a great thing to share. Hey, you missed a great webinar. Be sure and check out the recording later.